I'm going to wait just a minute to see if a few more folks join. Okay, we're going to go ahead and get started today. Again, thanks for joining us today for an OpenStudio live demo. My name is Chris Baldock, and I'll be leading the demonstration today. The webinar is scheduled to run for 1 hour today. Today we have, the attendees are all muted. We have quite a few attendees on today. It's too many to allow audio to be working for all of us. So we do have a question feature at the bottom right in the GoToWebinar questions bar. If you do have questions during the webinar, please feel free to enter them in the questions pane. We have 1 hour scheduled for today's webinar, and what I'd like to do, if there's time at the end, I will go through some of the questions that are submitted. If there isn't time, I will try to go through the questions again and make sure that some of the answers will be added to our website, OpenStudioTraining.com. In addition, the presentation is being recorded and it will be available at OpenStudioTraining.com. So a little bit about PSD. We are, again, a New York-based LLC with over 30 years of leadership in the energy efficiency space. We are an NREL-approved OpenStudio training and support organization, and we do a lot of work with energy efficiency, M&V, evaluation, and data management. And a bit about me. My name again is Chris Baldock. I'm the Vice President of Research and Development here at Performance Systems Development. I have about 15 years of experience with energy modeling tools. I've been following the OpenStudio ecosystem and its development for the last, I don't know, almost 4 or 5 years. And just recently, again, became a licensed provider of OpenStudio support and training services because I've seen the power in the OpenStudio ecosystem. So I'm a big believer of the OpenStudio modeling toolkit. What we're going to do today is go through a live demo, and as with any demo, we need a building. So for today's building, we're going to use a very simple building. It's a modular, relocatable classroom. I'll credit Triumph Modular for this plan. It's a very simple, again, you'll look at the plan, it's a 60-foot by 24-foot, essentially a double wide, with a pair of restrooms in the upper left corner. So we'll build this in OpenStudio today. What my plan for today, and the time we have, is to go through building the modular classroom in the SketchUp plugin, to then move over to the OpenStudio application, add some utility bills representing the modular classroom, model some heating and cooling systems in the classroom, examine applying some measures to the base building model using the OpenStudio application, and then I will transfer that application over into what's called PAT, Parametric Analysis Tool, and we'll look at running some ECMs or a suite of energy conservation measure improvements across the modular classroom. We'll run those both locally, and then if time permits, we'll at least try to start a cloud run to show again how OpenStudio integrates with the Amazon Elastic Computing Cloud. So let's just jump right in. We'll jump right in by launching the SketchUp application, and we're using in this case the SketchUp 8.0, the free version. There's an assumption here when you start SketchUp that you've already downloaded the OpenStudio plugin, and also there's an assumption that you've created an account on the building component library. When you create an account on the building component library, you'll get a key, and you'll need to insert that key here in the SketchUp plugin, and that will give you authorization to connect to the building component library from within the SketchUp plugin. So once you've installed the OpenStudio plugin for SketchUp, every time you open SketchUp, you will have loaded some information for OpenStudio. And I'll go here again. There's a Preferences tab in OpenStudio I want to make sure you're aware of. In particular, there's a template that gets loaded every time we start an OpenStudio project in SketchUp. This is our default template. So careful what you choose there. These templates, it shows again the directory where they live. And if we don't start a file by OpenStudio file, create a new model from the template, we'll get our default template. So good practice, always start with a template. I'm going to choose the secondary school again. I'll overwrite and I'll use my normal template in this case. What are templates? Well, a bit about that. Templates are just a large collection of default objects. And we'll look at those objects here in a moment. In fact, we could go look right now using the OpenStudio inspector to see what happens when you start a model with a template. Now, some of you are familiar with other energy modeling tools such as eQuest or Energy Plus or Trace 700 and so forth. OpenStudio is a lot more than just an interface on top of Energy Plus. It actually contains several abstraction layers. And those abstraction layers are embedded within the templates. So we have created nothing right now. We have a wide open SketchUp file, but you'll see here in our OpenStudio inspector we have a number of objects that exist. And those objects were brought into our model from the template. So just for example, we're looking at an object called building. This is not an Energy Plus object that exists in IDF, any sort of IDD or any definition. This is a pure OpenStudio object. And there's a number of those. Again, those are abstraction elements that are used within OpenStudio. It's really key if you're going to start building models in OpenStudio that you learn how to leverage these abstraction layers. If they're used properly, they can allow one to very rapidly replace elements within the model. And we'll talk a bit about that as we go through our exercises today. But again, it's a key feature if you're considering moving over to OpenStudio to get a very good fundamental grounding of this OpenStudio object model. So just while we're here, I'll go through a couple other things that are loaded in the templates. You'll see that the templates load things like design specifications for outdoor air. Oh, and there's a number of them. By space type, the templates load things like thermostat settings. They will load a number, again, of default objects associated with the sector that you started your model with. A very powerful piece of OpenStudio template modeling is an object called a space type. So I'm going to touch on this before we even begin our model. You'll see here I started my model with the secondary school template, and it brought in 57 unique space types, which you can see here at the bottom left. So these space types are driven by a vintage, essentially, an ASHRAE 189 2009, all the way to a CVEX pre-1980. So by vintage, by location, that would be an ASHRAE climate zone, and then by an activity, auditorium, cafeteria, classroom, and so forth. What is a space type? If you look here again at this object, OpenStudio space type, it's just a container. This is, again, not an Energy Plus object. It's an OpenStudio object, and it can be applied to a space. In this case, space types will be applied to spaces, which we'll look at those in just a moment. These are high-level containers that are used in OpenStudio modeling. So while we're here, let's go look at spaces. That's another OpenStudio abstraction. You'll see that our model right now has no spaces in it. We're going to build those in just a few moments in the SketchUp interface. So we'll close the inspector and we'll start building. What I do, the first thing I do when I model OpenStudio is I get rid of Susan here. She's sort of in my way. I keep snapping to her inadvertently, so we'll just delete her. I'll go to the top view and we'll start creating geometry. Now in OpenStudio, in the SketchUp plugin, it's important to understand there's actually two object models that exist here. There's a SketchUp object model and there's the OpenStudio object model. They exist in parallel. And while I'm here, before I start, I'll explain it. When one goes here to File, Save As, and they save a .skp file, they're saving the SketchUp object model. They're saving the circles, the triangles, the lines, the rectangles, and so forth, SketchUp objects. In parallel, if one goes into OpenStudio, File, Save As, they're saving the OpenStudio object model. So there are two separate models being created here, and it's important when you're working in the SketchUp plugin that you're saving your work as you progress. So if you're only doing work on an OpenStudio object, you would save the OpenStudio model. If you're doing some work on SketchUp objects, you would save the SketchUp file. I'll show you again as we move through here a workflow that accomplishes both of these. So in the SketchUp plugin, there's a number of ways that we can create geometry. I'm going to go through one way, which is to just simply use the SketchUp rectangle tool. I'm going to draw the floor plate of our relocatable classroom at 60 feet by 24 feet. And you'll see here in SketchUp, I just simply created a floor plan. Okay. And now I'm going to, again, adjust my view. I'm going to use SketchUp's measurement tool to lay out some key points for me to index off of later. I know from the floor plan that if I go over here about 8.5 feet, I will, 8.5 feet. SketchUp will index a point for me that I can use later. I'm going to go and lay another point off this, 8.5 feet again. This is just simple SketchUp stuff. Oh, my apologies, got that wrong. 8.5 feet. Sure, and then one more point I'll use later on. 8.5 feet again. I'll use those again for indexing my next step, which is to create some interior partitions. I'll use SketchUp's line tool. We'll just go down here. Oh, actually, I need one more point here, so I'll go back to the measurement tool and I'll create this at 7 feet. Okay, so again, I'm going to create some more interior partitions here using SketchUp's built-in tools. No worries if I can certainly use the eraser tool and clip this as well. And now I have the floor plan of my relocatable classroom. Here's my classroom space, my men's bathroom, my women's bathroom. But these are not OpenStudio objects. These are SketchUp objects. I have full functionality. I can certainly go and erase. I can redo. There are all the tools that I have at my reach in SketchUp I have as well in this interface. So my next step here to create the geometry would be to go to extrude it. And I'm going to stay in SketchUp here. I'm going to select my objects. I'm going to use a feature here called experimental workflow, and I'm going to create a SketchUp group from the diagram. So essentially we created the floor plan of the diagram. I'll just make this a 12-foot tall volume now. And what did I just create here? Well, now we're looking at 3 SketchUp groups, group 1, group 2, and group 3. Again, I'm still in SketchUp world. I have not created a single OpenStudio object at this point. I'm simply creating SketchUp objects. And there's reasons for doing that. It's easy in the SketchUp plugin to get the 2 models uncoordinated. So the workflow that I recommend is to stay in SketchUp as long as you can, using SketchUp objects, and then begin to convert those objects into OpenStudio objects, not to do both. This is a very simple model, so to demonstrate that workflow, I would just simply take my OpenStudio, my SketchUp groups, and we have another script here that would say convert those groups into OpenStudio spaces. Okay, there. So we've just now we've created OpenStudio objects, and those objects we created were spaces. So if we go now again and look at our inspector, we'll see that we now have 3 spaces that were created. And good practice again would be to rename these. I usually work with multiple monitors, so it's a little easier to see this. But for example, we're going to call that space the classroom space. We're going to call this space the men's restroom. And we'll call this space the women's restroom. Okay, so very simply again, we have full access to the OpenStudio objects through the inspector. You'll see here I just simply name them, but I could also assign values to other parameters or other objects that belong to the OpenStudio space object. So let's go back here for a moment just again to see what we've got. Okay, our next step here is to back up a bit and see within the SketchUp interface, I'm actually outside of OpenStudio right now. If I want to access a space, I double click in it, and you see that space becomes active. So I'm now in the restroom space, classroom space. If I want to draw geometry, windows for example, on this surface, I need to have that as the active space that I'm working in. So once again, I'm going to use the measurement tool. I'm going to lay the bottom of the windows here. I'll just give me some lines to index off of. Okay, and if I go back, I believe there were 3 windows here that are 4-foot by 4-foot windows, so I'll just simply, I'm inside that space, I'll select the rectangle tool, and I will draw a window up in the dimensions window up above at the top left, top right. You'll see I'm describing the window dimensions as 4-foot square. Okay, we've got one window. It's very easy using SketchUp tools to hold the control key down, select the move tool, and I simply copy that window. And I could copy it by typing in a distance in the upper right column. I'm just going to put it there, and I'll just to make sure they're the same, I'll take this window and I will again hit the move tool, and I'll index off this point and make it there. So there's my 3 4-foot by 4-foot windows on that face. We'll do the same thing back here on this side. I'll go back and I will lay a line so that I can index off of it. Okay, then I will again create my first window. Oops, and again, I have full access to the SketchUp tools. I can put that window anywhere. I can put it here, and then I can also again select it and simply move it, anchor it to my line, and then also I could go and select that window and yet again use the move tool and copy instances. Now I'm just going to copy all 3 again just to make this go a little faster. Click the move tool, and let's put those down there. Okay, and then the last piece on this, there were a couple windows over here. I'm just going to draw them rapidly just to keep us moving through this exercise and just place them roughly in the right area. Of course, if you were to do this, you would index them correctly. So we have a rough model here. We're missing doors, and if we go back and look at the model, our doors were in the center, just a standard 3-foot by 7-foot door. So we could go here, pick the midpoint, again get the dimension. That would be 3 feet, 7 feet, and then we could also slide that door to the left or right to center. And we do the same thing on the opposite side. The door is very close here. We make sure we're in that space, and we'll again draw a 3-foot by 7-foot door. Okay, so we've created, let's see, these 2 spaces, if we back out, they don't have windows, they don't have anything in them, so those spaces are actually correct. We've essentially created the geometry here for our modular classroom. Now, again, you notice that OpenStudio, the SketchUp plugin, knew that this was a door because it was anchored to the floor. It knew that this was a window because it was not anchored to the floor. But what about the properties for these things? I just drew these things, but what are they actually defined as? And one way to look at that would be, again, to go to the inspector, select an element, and it will take me directly to that element. I can see this is a fixed window. I don't have a construction name here. And that doesn't mean that I actually don't have a construction here. It just means that it was not assigned at that object level. It could be assigned at a higher level and just be receiving that through inheritance. And that's, again, the beauty of OpenStudio is if you begin to understand these inheritance structures, you can very rapidly model. So I'll show you in a moment what I mean by this. The highest level in an OpenStudio model is what's called a building. The highest object that you can have in your model is a building object. And everything else is a child of this object. So you can see here in this building object, I have default construction sets and default schedule sets. The default construction set is filled in, the schedule set is not. What this means is every surface that's created in this model is inheriting its properties from this default construction set that exists at the building level. That's a lot of words, but again, to really understand that, if I were to replace this, I would replace every single, the properties of every single surface in this model, unless I specifically overrode them. So just to go a little bit further on this, going down one more level, underneath the building would be a category called the space type. And again, we'll move to that. Let's see here in the inspector, we'll see the space type listed right there. Just take one space type. You'll see again, oh, look, there's no default construction set here. So in this case, when I apply a space type to these spaces, it's not going to override the construction set that was applied at the building level. There's a lot of words again, but it's very, very important to understand what that means. These constructions are inheriting their properties from the OS building the OS building object, not the space type. Okay, to get this model a little further so we can use it in the OpenStudio application, let's do a few things. You'll notice here, right now, we don't have any thermal zones in our model. And I'll speak again a bit. A thermal zone is an Energy Plus IDD or an IDF object. It's also an OpenStudio object. Thermal zones are collections of spaces. So let's go ahead here and build a thermal zone, and we can do that very easily using our inspector just by creating a new thermal zone. Let's call this classroom plus restroom. Okay, no problems here. And again, we have all the same access to all the objects that Energy Plus would assign to a thermal zone. You'll notice these are the same definitions of objects. We've created a thermal zone. Now if we go back to our space, you can see that we can now go in here and assign the thermal zone. So I'm just going to go in right now and assign thermal zones to my space. It's very simple, very easy to do. You can also see that I could have assigned building stories, I could have assigned design specification outdoor area names. Many of these that are blank are not blank, they're being inherited from other objects. And that's the part, again, I want to make sure I emphasize in this short webinar. So yet again, here's an opportunity at the space level to define a default construction name. If I were to choose this, I would essentially do, I'm hard coding it. I'm hard coding this space to have those values. Now we're in the women's restroom, so right here, it would have constructions as defined by this construction set. So let's go back and leave that blank. I don't want that to happen. We don't want that to happen. So we've gone through the basic creation of geometry. We've gone through setting up some spaces using OpenStudio, creating a thermal zone, and assigning the spaces to that thermal zone. And really, the strength of the SketchUp plugin is form and fabric. It's a very easy tool because when we move to the next step, we're no longer going to be able to alter this form and fabric. When we migrate to the OpenStudio application, the XYZ values of these surfaces are going to be locked. We won't be able to change them. So if we need to change the form and fabric, we do that in the SketchUp interface. Before I move on to the OpenStudio application, I'll just say that everything we've done so far in this model could have also been done by calling the OpenStudio API. Either calling it through Ruby scripts or through C# scripts or by Python scripts. So there is an API using the OpenStudio software development kit that allows one to create the exact same steps that I created here, opening templates, creating spaces, extruding them up, and so forth. The same functionality is available in the API. So it's always good practice, and I should have done this before, it's always good practice. Save early, save often is the mantra. So let's go ahead and save this. My way, again, I'm saving the OpenStudio model is to date and timestamp it. We have 123 right now, so I would call that 1323. And now I, again, have a record of my model. To move over to the OpenStudio application, we'd simply launch OpenStudio from the SketchUp plugin. And it's interesting to understand the link between these two. So we just launched this OpenStudio application. If we make a change, for example, load a weather file into our model, which we're going to do here right now, I will load an Energy Plus weather file here. Find that directory. I'll just put this model, for argument's sake, let's stick it into Chicago. And we'll load design data weather for Chicago as well. And when we save this model, you'll notice back here in SketchUp it says, hey, something's happened. Do you want to reload this? So there is a link between the two. When we change something in OpenStudio and save, we can reload it in SketchUp. But it's a one-way link. In other words, if we were to go here right now and launch OpenStudio, we'd launch a second instance. We don't want to do that. So it's careful to understand, very carefully understand this linkage. So now we're over here in the OpenStudio application. We've got our form and fabric created, and we've got our zones, we've got everything. Let's go down and see what the minimum we need to run a model, because that's really what I want to look at first, is the minimum that we need. And we can run a system called ideal air loads. It used to be called purchased air. And if we're going to do that, we just need some thermostats. We have our zones, we have an ideal HVAC system, we just need some thermostats to control the model. In the OpenStudio application, we have an option here. We can do what's called load library, which means we could load template thermostats from any of these, a number of these templates. I'll just load large office now as an example. And in general, if you look at the OpenStudio application, it has a consistent look and feel. So before I assign thermostats, let's cover that look and feel. If you go on the far left, you'll see the workflow. that the OpenStudio application supports. It starts here at the top where I loaded the weather file, for example. It ends at the bottom here where I actually view results. There's my run simulation. If you click on any of these buttons, you see this is a schedule section. This is my run simulation section. This is my site section, and so forth. So this screen changes based on which button you choose here. And then again on the far right, you'll see a common look and feel, which is often a My Model tab, a My Library tab, and an Edit tab. Now, My Library means my local library. My Model means things that are actually in this OSM file. They're not stored in a local library. They're in this OSM file. They're contained and used in this OSM file. So if we go back here to where we were a moment ago, we're going to run the purchase there. I'd like to go look at the library of schedules and see if we can actually let's look at My Model schedules for a cooling thermostat schedule. And I'll see here if I go down, here's a secondary school heating set point. Throw that in. Here's a secondary school cooling set point a little bit further. Just drag and drop. I've anchored these schedules now. And I have one thermal zone with 3 spaces. And that's all I need. I can simply run the model right now. Of course, it's going to ask me to save. I'll overwrite my timestamp. Hopefully that wasn't a bad idea. And we'll see if we can get this Energy Plus run to run. So we're launching Energy Plus right now. I'm running this locally on a laptop on a single processor. We can do some things to make this run a bit faster. But we can see again what's happening, stepping through the year. The progress bar in the upper center. And let's see, we are done. We finished. So when we're finished, our results tab will be populated. You'll see here again, I have ideal HVAC systems. I don't have anything here except some electricity for interior equipment and interior lighting, plug loads and lighting from our templates, from our space type templates. I also have some load information here. You'll notice district cooling, and millions of BTUs, and district heating in millions of BTUs. So if I'm simply concerned about optimizing a model in terms of its loads, I don't need to define any complicated or complex HVAC systems. I don't need to define outdoor air management strategies. I simply want to look at optimizing form and fabric. If that's the case, I can run with this ideal loads model and continue to move through an OpenStudio workflow. But let's go a little more complicated here. Let's put the simplest HVAC system that we can, which would be, in this case, an all-electric packaged terminal heat pump. We'll simply drop that into our drop zone for this thermal zone's HVAC equipment. Common look and feel here, when we drop something in, over on our upper right, we can now edit that. So let's just, again, make this this is a PTHP. And we'll call it number 1. And similar, if you're familiar with Energy Plus's object definitions, this is what's called zone equipment. It, of course, works on a zone, on a thermal zone. And if we scroll down here on the right, we'll get all the objects that make up this zone equipment. So, for example, this PTHP is made up of a heating coil, DX heating coil. Maybe I'll change the efficiency to some different COP or equivalent HSPF. Maybe I'll go down here to the cooling curves again that are defined. If you scroll down, you'll see all the objects that make this up. Here's the cooling system, the DX cooling coil. Make that a little bit less efficient, maybe 2.2. So we have full access again to the Energy Plus object. However, these do come in defaulted to some sort of reasonable value. You can't change those reasonable values. They come in as fixed defaults. So it's a good idea again to review these, whether they're new construction or retrofit or what have you, whether they're appropriate values. So we simply added a thermostat, we configured a PTHP, and we'll go back in here again and rerun the model. While it's running, I should have made it run a little quicker, but I forgot to do that. We can do that here in just a moment. We can always go back and review other parts of the OpenStudio interface. And you'll see as you go through this interface, you'll see things that are green versus black. The green values here, when the object is at a higher level. And that again shows the OpenStudio object hierarchy earlier about the example. The object described at the building level were trumping all other objects. So let's just take an example here where we could, for example, look at a schedule set. Schedule set is an object, again, that doesn't exist in Energy Plus. It's a collection. It's a collection of schedules. And over here on the left, you see the schedule sets that are in my model. They're actually in my OSM. Move toward the center, you see what is actually in a schedule set. Well, it's a number of default schedules. And again, I could apply this schedule set to any space type, or to any building object, or to any space object. There's 3 different places I could apply schedule sets, and they would inherit down from that point. Okay, so moving on again, just briefly showing how Energy Plus handles these objects, because it has a number of differences between OpenStudio and Energy Plus. One is in loads. You may be familiar in Energy Plus with how we describe lights, people, equipment, gas equipment, other equipment, steam equipment, and so forth, as simple IDF objects. In OpenStudio, we do it a bit differently. We describe a definition. So again, here you're seeing a number of definitions of what's in my model. Here's a number of people definitions. We've used one called the secondary school classroom people definition. So we've said in that large space, that large common area of our modular classroom, there's 0.023 people per square foot. And it's roughly a 60 by 20, 60 by 24 space, subtract out the restrooms. For example, how many people are in that restroom area in our model? Let's see that. Let's see, it looks like far fewer, 0.009 people per square foot. You'll notice these are peak values. There's nothing in here about the schedule. How do these people move in and out of the space? That's not a part of the definition. So again, that's an OpenStudio abstraction that we can use. We can apply this definition in several different places and then anchor different schedules to those places to maintain one common place where we can change this definition, for example, of a measure. Okay, so did we get some results here? It looks like Energy Plus did finish. You'll see now we do have, instead of purchase heating and cooling, we do have some cooling and some heating here. And I want to point out that this chart in this results viewer it looks a lot like a chart that eQuest generates, a table and a bar chart and so forth, but it's not. This is a chart page, which is standard documents, and it's an interactive chart. So you see here as I mouse over the values, this is a very interactive reporting tool, and it's within OpenStudio. It's very easy to take this chart and turn into a chart, turn into a stack bar chart like this, or a graphical format that this data can publish on web pages. So that's an advanced feature of OpenStudio again. Publishing reports using the D3 engine. So we got some results here, just showing that quickly. The only way, again, that I can recommend you getting familiar with the OpenStudio application is to just use it. Literally go deep with it to see. And I'll point out again an example when we go down here to the Facility tab, right here, when you can start to see what's happening in this model, big picture. Let's sort this by thermal zone. We only have one thermal zone in this model. And we have 3 spaces in this model that are composed of that thermal zone. And again, you'll see this green text that says, oh, the space type was inherited. That's an inherited object. Now I can drill down in here and say, okay, let's look at this particular space, the classroom space. Let's look at the walls in that classroom. Let's look at this particular wall and that particular subsurface. That happens to be a door. If I wanted to, for example, change the properties of that individual door, it'd be very easy. I go over here to my model and I just simply drag and drop and replace the construction for that door. Otherwise, it's inheriting that construction. So general form and fabric you do in the OpenStudio SketchUp plugin, but if you want to do refining of the form and fabric, you do it here. This is really the best place to manipulate the properties of individual surfaces and subsurfaces. You'll see down here again the XYZ coordinates. I can't edit those. But I certainly could go back here, save, pop back over to SketchUp, load it, and now I have full access to my SketchUp model. I could go in here and stretch and pull and do all sorts of things with geometry, and then close this and reopen it, and my geometry would also update. Okay, so showing that, I want to show one more feature that exists here in the OpenStudio application, which is called a measure. And before we do that, let's make this model run a little faster. So I want to change a few things. I have access to the time step. Let's make this hourly instead of 15 minutes. I'd also like to cut down on this 7-day shadow calculation. Let's make that every 30 days. I'm not recommending you do this in your actual projects, but you'll see a dramatic speed increase just by those two factors. And now I want to talk a bit about this section here in the OpenStudio application called measures. So you'll find there's a lot of things you can't do in the OpenStudio application. They're not available. For example, one that I would like to do in this model is to add exterior lighting. Nowhere in this ribbon on the left will you find any capability to add exterior lighting objects to your OpenStudio model. However, there is a way to do that. There's a way to add anything to your OpenStudio model, and that would be by creating a measure. I spoke a little bit in the webinar a few weeks ago about what measures are. We don't have enough time here to go into the detail of measures, but I will say that they are formal descriptions of changes to a model. They're more formal descriptions of a change to a model. And in this case, there's a number of measures that live out on the building component library. For example, we could go here and simply clicking if you have a connection to the internet. And here are the measures that are available in the public part of the building component library. So I'm just going to download as an example, I don't know, all the people measures. How many are there? Let's see. People schedule measures, there are none. People characteristics, there are none. Okay, bad choice. How about equipment controls? Okay, I'll take that one. Select it, and again, download it. The OpenStudio roadmap has a number of these. The measures are going to increase. The number of measures in the building component library is going to start to grow radically, and the measures that are going to be there are the measures from the ASHRAE Advanced Energy Design Guide. So these are measures that NREL has created. We pull them down from the BCL, then we simply close this tab. You'll see here now I have a new measure that's showing up in my tab within the OpenStudio application measure subtab. Let's say I want to apply this. I just simply drag and drop it. And then I select it and configure it on the right. Now I'm going to go back and do the one I talked about, which is to add, again, I'm going to my library. I want to go to exterior lighting, which is right there at exterior lights. I'm going to drop this in as an always run measure. And I'm going to configure it. So NREL has written a measure that adds exterior lighting to my OpenStudio model. I'm going to make it to KW, exterior lighting. You'll see here the measures have some text here. For example, what's the schedule for this? The schedule is going to be sunset to sunrise every single day. Okay, that works. If I had to change that, if I really wanted to go and I'd make a copy of this measure, go in and change the coding, change the formal description so that it met the schedule I wanted. So it's very easy, again, to edit these measures. So and I've saved it. Probably should be doing save as with timestamps here. So I leave myself a trail because it is possible, quite likely actually, that you might get a crash in OpenStudio and you might have to revert to one of your older runs. Here again, everything's working well. If it wasn't working well, I'll just go here and explode this out. If OpenStudio for some reason did not run, did not solve, you go to the tree button here and you can explode out the workflow. You can see what's happening. We're going to see this in more detail in PAT, Parametric Analysis Tool, in a few steps, but just the general workflow of what happens. You start at the top, you see here that OpenStudio takes the OpenStudio model, generates an IDF model, it eventually runs it. The most important thing here is there's a file. Those of us who use Energy Plus know this file very well. And EPLUS.err, we can always look at the file and see if a file crashed, why? Why did it crash? You'll have a severe or fatal error, we figure out why, and we fix it, and then run it. I don't think I've ever had a file run without warnings. There's always some information in that ERR file, but again, sometimes the warnings are just nuisance warnings, like these three. Yep, you're right. Sometimes they are actually, I should pay attention to them. Okay, so we'll close this out. We'll go back into our OpenStudio application. We ran the model. And I don't know if you noticed there again, let's just do it. It's going to run super fast now because we trimmed down the shadow time and the time step. You'll see here again, the very first step, it blew out that measure. Now it's running. It'll take about 15 seconds to run this annual model. And processing at the end, creating the D3 output. And once it's finished, we can again review. And now we'll see it's a little hard. There is an exterior lighting component there for each month based on the hours of sunlight. So it's, now all that aside, what I wanted to demonstrate there, the point of the demonstration is that through measures, whether they're custom measures or whether they already exist on the NREL VCL, you can extend your OpenStudio model to include just about anything that you can do in an IDF. At the same point, I'll take a moment now and say, if anytime we want to, we can go out here and export an IDF. Say, oh, this is as far as we can go. We're going to take it into another tool. We're going to work just in the IDF editor. Fair enough. We've used OpenStudio to get the geometry, form, and fabric. We've gotten 90% of our work in, and now it's time to go in and do the other stuff that's not supported in OpenStudio directly in the IDF. So that's always an option as well. You can also import an IDF into this, but I'll point out that you can't actually import on top of. If I import this, it's going to destroy the file I have right now. It's like import, create new functionality. Okay, so we have here a seed file. I'm going to make it a little bit more complicated just to show you one more feature, and then we'll move over to the parametric analysis tool. This is a piece of zone equipment. Let's just drop that right off the bat. We deleted it. We have no equipment in our model right now. Let's use this feature, which is the HVAC systems feature in OpenStudio, and let's create an HVAC system. Very simple. We can just go over to the green plus sign. You'll see a number of templated systems here. The templates are in line with Appendix G, 90.1 Appendix G, similar systems. At the very bottom there are blank templates, blank air loops, blank water loops, plant loops, and so forth. Let's do our similar, very simple package rooftop heat pump. We'll just add that to our model, and you'll see, oh, OpenStudio just built out a number of objects for us. It built out on the supply side of an air loop, the demand side of an air loop. It built out a outdoor air system. It built out, you can click on these, DX cooling coil. It built out a DX heating coil, and it built out the electric resistance backup coil. And of course, it gave it values. It gives these default values. It also built out set point managers. If you were doing this by hand in the IDF, you would this might take you a while to get it right. So again, you can build this out now. Of course, I could always export the IDF, no problem. You can always do that as well. What we need to do now is very simple. We will just choose our thermal zone, drag and drop, and we just assigned our common classroom zone to this built-up rooftop package heat pump. Now, it's easy here. If we had 3 or 4 zones, we could just assign them 1, 2, 3, 4, and you'll notice here when you select this set point manager, it says, who's the control zone? So this is our multi-zone system where I have a master zone and a bunch of slave zones. Very easy, again, to create that, just drag and drop. Now that I have a complete built-up air system, I actually can have an economizer, which I couldn't have in the zone equipment. So let's say here we have a, I don't know, how about a fixed dry bulb economizer? And of course, we go down here and set the limits for that dry bulb economizer. We have full access again to the Energy Plus object definitions. These follow the Energy Plus object definitions completely. So now that we have that, let's go ahead and run our model. And we continue again to build up complexity in our model. I think after this one runs, I think we're going to move over and take this model into PAT, the Parametric Analysis tool, and run some simulations against it. The key point here, the key takeaway is we're trying to build what we call a seed model. It's our best case of a seed model. We'll do one thing before we do that. We'll put some utility bills in really quickly. So if you see here, I'm going to say an average utility bill of about 4,000 kWh per month. So let's go back in here to the utility bill tab. In order to do that, we have to go pick a year, pick an actual year. So let's say our bills, just for argument's sake, they're going to be 2012. And now we go back and we can actually enter the utility bills. Same look and feel. I select electric bill and I select the plus sign. I'm adding one. I'm going to do this very fast, but you'll get the idea here. Start number and date. I'll add a new period. So it starts with 2012. I'm just going to add 12 periods here very quickly. And that will cover my year. I need to have at least a year in there. I know this isn't an actual bill, but it's going to work for the purposes of our demonstration. It's going to very rapidly plug in some fake bills. And this is how you do it. Again, unless you're using the software development kit, you have to hand type these in. There's not a way to import them. KW is optional, cost is optional. So we have bills now. If we save this model, and let's go ahead and make a new directory here in the OpenStudio webinar. I will call this 1345 seed. And I'll go in there and call this again our 1345 at seed. Seed meaning a seed model. So I've got a model, I'm happy with it. I want to see about calibrating it next. The one thing we didn't have time to do in our time would be to add service hot water. Really should have done that to start to calibrate a real model, but I'm not going to. I'd rather take our time to finish out showing Pat and high performance computing with the Amazon EC2. So we'll simply close the OpenStudio application. We will go over to OpenStudio, and by the way, I should have told you, I'm running on OpenStudio 1.2.3. That was just released yesterday. It's available on the NREL website under the developer section, and we'll launch PAT, Parametric Analysis Tool. We'll go in and start a new project. We're going to call this our 2/11/2014 PAT example, where we're going to stick this somewhere. And again, there's a potential that we might create a lot of data here, so we have to be careful we don't stick it somewhere we might run out of room. I'm going to stick it here on my root drive under the OpenStudio webinar. I'll make a new directory here called example 2/11/2014. That's my folder. Okay, so we've opened up PAT here, Parametric Analysis Tool. Our first step then is to load a seed model. Load in our seed model, and we will just steer ourselves to that OpenStudio file that we just created a moment ago, which was under, I think it's OpenStudio webinar, right, 47. No, we can use that guy, that's okay. Okay, so we load a model into PAT, and it had a measure in it already. Remember that the measure for extending out the exterior lighting, and that also was brought into PAT. So the first step in the PAT has a workflow similar to OpenStudio again. You drive from top to bottom, left to right, is to add measures. So what are we wanting to look at here? And I'm about 10 minutes left here, so I'm going to put some quick ones in. I'm going to first add a measure here to reduce nighttime electric equipment. Okay, and I simply drop this on the new measure group. And it becomes it's a group measure. Now I'm going to configure that measure and say, okay, let's drop down my restroom equipment. Actually, because it's classroom, we can find the classroom will be a lot better. That guy. And let's drop it down to 0.1. Okay, fair enough. We've configured that, and now let's give it a unique name. 0.1. And again, we have to just keep track of this as we're setting up a simulation study. Now we could go back again, drop that measure again, configure it. Let's make this not quite as aggressive. How about 0.2? So again, the fraction of 0.2. Same assignments. And we have these other inputs again, or if you wanted to get more detailed, you could again configure the schedule for reducing the nighttime loads. So there's an example of one group. Let's add another measure group here. Oh, I don't know, maybe this one we have in our model, we could go and reduce space infiltration. And the first one will reduce it by, let's go big here, 50%. So, and not that this is realistic, but I want to make sure we get a signal when we run this model. Okay, and then we're going to do it again here with something that might be more realistic. We'll drop it, configure this one, let's say 10%. Okay, and again, you have to look and see how to configure these in more detail. The idea is we're just simply, again, organizing measures that are going to be in our project. This is what we call scenario management. We're setting up all possible measures that we want to research in our simulation study. And we're just setting them up here. Maybe there will be 3, 4 levels, 5 levels, a minimum of 2 levels at least. Probably should have a 3rd level in there so you can detect linearity or not. You know? And when I do these, I do code minimum, maximum achievable, and then something in between the two. So that when I review the output, I can see, first of all, what's the impact of going to code minimum, what's the impact of going to maximum achievable, and then the third point tells me, is this a linear output or not? I can always go back in and add more measures if I need to. Let's add one more in here while we're here. Let's add, let's see, maybe, oh, what do we have for this guy? Add exterior lights, we already have that one. Well, we can go down to the BCL and pull something down. So I just said add measures from the online BCL. I'll find something interesting if it's got to be applicable. Oh, I don't know. How about, yeah, let's put a better roof on it. Sure. And this is part of the fun of simulation. I think it's an awesome teaching tool because I don't actually know whether the roof has any impact on this model or not, or whether it's going to be negligible. I'm about to find out. And I'm going to do this again by going back to BCL measures now on the envelope. I have 2 here. There it is. I'll drop that into a new measure group, very quickly configure it. Let's go deep again, R50. Make sure I can understand this. Leave me a breadcrumb trail for later. I'll go back again. I'll throw one more in there. Going to something more reasonable like R, let's say R35. Okay, so you get the point if you're following here what an analyst would do. If they're setting up a simulation study, they're just setting up the measures. The next thing we need to do is to go and group those measures into what we would call packages. So there's lots of ways to do this. If I just simply select all of these, you'll see here, and I hit create one for each selected measure, I'm creating a run. An individual run, sort of a non-interactive run of all of these. Sure, that might be one way I want to run a study. The other way would be, and I'll just clear all of these real quick, and we'll run some here in just a moment, is I might pick one out of each combination and say, create a single run, we call it a package, with those 3 measures in it. Okay, and let's create a second one. Yep, and let's create a third one, and let's create a fourth one, and let's create a fifth one, and on here. Oh, can't do that. Okay. Okay, so again, we can just go on here and let's actually create all of there. So we have a number of runs here now. We just created baseline run, of course, and the others. And simply, if we want to, we can just run it locally. Boom, we've run it. So we're launching a seed model. We're running this locally. The thing that's interesting about PAT is it actually takes, the machine I'm running now, the laptop has 4 cores. And you'll see here in PAT that we have 3 simulations running. So it's n-1. It's going to run them in parallel, which the OpenStudio application did not do. This is a local run running on a 4-core machine. I have yet to turn on the cloud yet. I'm going to talk about this while it's running. This thing running locally just basically means PAT is going to run, finish the 3, it's going to run 3 more, it's going to run 3 more, it's going to run 3 more. So it's going to just continue to spawn them and manage them locally. While that's running, let's go talk about the cloud. And the cloud here in PAT is very easy to access, almost too easy. One would go to Amazon EC2, the Elastic Cloud website, and sign up for an account. And when you sign up for that account, you'll get a couple things. You'll get an access key and a secret key that you need to input into the PAT screen here. That gives you the keys to the car. Now you can turn on the Amazon engine very simply. The next step, if you're going to do this, is to choose what configuration you want to run on the cloud. So you see in the background these again, keep running while we're working. The way the cloud works is you have what are called server nodes and worker nodes. And of course, you want the smallest server you can have, which is this number here. It costs about 82 cents to run it for an hour. And you can have a single size worker, but you can have up to 19 of those. So again, it won't let me put in 20, I can only have 19. I really only want one to make sure this is going to work, because this thing costs about $4 an hour to run. and it's going to run 16 processors at once. So instead of my little local machine here running 3 at once, I'm now running 16 at once. Of course, take that times 19, I could run several hundred of these in an hour. The thing to be really aware of when you work with the Amazon Cloud is that you get charged for any part of an hour. And I'll launch one of these just so we see what happens. We've got about 5 minutes left. Let's see, that's probably just about enough time to spin up the cloud. Let me first trash my results just so I can force the cloud to run. I will add a new measure here. Oh, I don't know. Sure, I do want to proceed. Yep, so I just trashed all my results that I made locally. Now I'm going to go here to the cloud again. I set my settings, I continue. Okay, good. Now I'm going to turn on the cloud. And it's going to force me to run the baseline model. So again, if I just select only the baseline model and run it locally before I launch the cloud, it's going to take about 20 seconds. While we're doing that, you can see and blow out in PAT, you'll see the baseline running. And each of these categories, you can see a lot more detail, like what's actually happening. Right now, this model is running, and you see the Energy Plus. This is basically the ERR file. It goes from that. It did run, didn't give us any warnings. It's done. So now I can turn on the cloud. I started the cloud up right now. I asked for one instance of a server node and one instance of a worker node. And it's going to take about 5 minutes to spin that up. Spin it up means what's happening is Amazon has allocated 2 machines, 2 virtual machines to my account, starting to charge me effective that button. And it's installing OpenStudio, it's installing PAT, it's installing Energy Plus, it's installing all the dependencies that are needed. It's literally just like a fresh install of a new machine. It's called an image every time you click that. So now what's going to happen until this comes up? In the meantime, there is a button here for monitoring the use. And if you do cloud runs, this is a very important button. You can go to the cloud and manage your account. So assuming you have an account, I have an account, let's log on and look real quick. You can log into that account and you'll see what's actually happening on the EC2 side. And nothing is happening right now, but again, in about 2 minutes, maybe we'll see stuff start to happen here. We'll see instances start to form, and we'll see our runs start to launch. Now, we actually haven't launched those runs yet. If you go back to PAT, and you see here, all I've done is run my baseline. I would like to go ahead and, when the cloud is up and running and ready to go, this will turn green and we can launch it. Not yet. It's still creating the images. It's still ramping up, essentially. This is really powerful. So I mentioned before that it costs about $4 to launch a 16-core machine for 1 hour. And, you know, it took, what, about 30 seconds or so to run one of these single zone. Now, again, I was running with the hourly time step and the 30-day shadowing calculation. Nevertheless, even if it took 2 minutes to run a single simulation, you can run a lot on 16 cores in an hour's time. And that will cost you $4. So that's very interesting in terms of changing the way we approach energy modeling, where we actually want to explore the space. We actually want to set up simulation studies that explore the edges of the space and then start to explore the interactions within that space. And that's really what PAT lets us do here. Now in our classes, in our OpenStudio classes, we talk about how to do this both within PAT and also within a spreadsheet management tool. And that opens up a lot more power in terms of being able to configure PAT using a spreadsheet. Right now you're sort of stuck using the parametric analysis tool interface to configure what might end up being 40 measures with 3 different levels of performance for each measure. This can get quite unwieldy. There is an alternative, which we go into deeper in our OpenStudio training classes, to drive all of that with a spreadsheet interface. So let's see what's happened here. Let's go back over to the EC2. Let's refresh the web page. And now let's see what's happening. Well, we've got our instances. So we've got 2 instances. We're on the books here. We're paying. There they are. This is our server node, and this is our worker node. And they are running. They're still what's called initializing, and you'll see over here, if we go back to PAT, that still hasn't turned green. So they're not ready yet. They're still coming up to speed. So again, I want to say this is one of the most powerful features of OpenStudio is the ability to run hundreds, if not thousands, of simulations for maybe 50, 100 modelers, something like that. I've spent so much time in my modeling career just sitting in front of desktops, laptops, servers, waiting for the simulations to finish. And those days are coming to an end. So now I'm spending my time on understanding how to view the results. And that's sort of the next paradigm for where we're taking this analysis. I can't show you right now. We will run on the cloud here as soon as this comes up. I'll continue talking. I know we've hit our 2 o'clock window, so those of you who have to leave, let me just say a few words, and I'll continue on for a few minutes. Within PAT, that's the key right there. You can export XML reports after this is all done, and you'll get a single XML file that contains the results for whatever is in this OSP file. So now we're not in OSM anymore. This is an OSP file. And again, we're not going to be able to mess with this while the cloud is coming up. But that's a simple demonstration of the cloud in action. For those of you who do have to leave, I just want to remind you real quick, we are actively training people on how to use OpenStudio, the OpenStudio application, the SketchUp plugin, and PAT with a spreadsheet and other tools, how to leverage the power of high-performance computing with simulation. And we do have a couple of trainings coming up in March, both in Philadelphia and in Washington, D.C., that we're still taking seats for. We're still selling seats for. And we also, of course, would offer services for measure development and consulting. I'm going to go back again for those of you who have to leave. Thank you for joining me. I'm going to stay around here just to make sure this pattern run works. So let's just see where we are with that. One moment here. And we'll go back to the cloud. It's unfortunate we do have to reload these tabs to make sure they're coming up. And I said it does take about 5 or 6 minutes for Amazon to what's called spin up these images. So we're still waiting. We're paying for part of an hour as we speak. It's probably a good idea to plan on running this thing for as close to an hour as you can. So it's just part of the overhead. Oh, there it is. The cloud is now active and ready to go. We will launch it. And now what's happening again is our simulations are not running locally. They're running on this 16-core machine. We can actually go over and see what's happening under the hood if we go take a look at this address right here. Let me find it here. Oops, pardon me. There we go. That address right there. That's our. So we can open up a new window, and this is going to be, oops, should be spinning up here. That's our worker node that we should be able to connect to. And let me make sure on that. I think that was the worker node. Try that one. In the meantime, we'll go back over here again, and let's see. Ad is still starting, still running. We've been paying now for 6 minutes. We have the 2 instances running, and we'll see here if we're able to spin up. I'm not able to get this for some reason. Okay. Well, that's all. Oh, now they're running. Okay, so checks are passed. It will be launching. We need to be patient again the first time we spin these up. It's very important to manage this within Amazon's interface because we are, if we don't turn this off, we will be billed. Basically, you put a credit card in and you can set some thresholds in that will shut off at a certain billing point, but otherwise, you're cranking out $4 an hour per 16-core machine every minute, every hour that this continues to run. So let's go back again and see, okay, now all of them are running in parallel. You see here again, they're listed as running remotely. They are running. We should be done here fairly soon because those models ran in like 30 seconds locally, so I can't imagine they would take very long. Once they're done, we will we're downloading the results. See how they're showing up now as finished. Okay, And now we can, again, in the last tab here, we can actually see the impact of each of those design alternatives. If we were careful about naming them, we'd be able to understand this a little bit better. We see some high-level impact here. Of course, we can always go and download the XML report. And then the final step is we could pick any one of these alternatives and open it up into the OpenStudio application as our next step. So there's the important point I want to point here. If you want to download results for this, you go to the screen, you select them, and you download what are called detailed results. Now that's going to download the entire what's called node. It's going to have all the information that was created in a local run, so you get the detailed whatever output you asked for. Here on the other screen, the run screen, you can simply download summary information by clicking those arrows on the right. Now I'm going to turn the cloud off here because I just want to make sure everybody understands how this works. And when I turn the cloud off, the data goes away. The data literally disappears. It cannot be retrieved. If I don't go to this screen here and download all the detailed results I want, if I turn the cloud off, they're gone. I'll have to literally recreate them. So you can see it. You have to understand this workflow. Very important to understand this workflow. We didn't quite get to this calibration piece. I'm sorry, we're running over time now. I'm going to have to stop the webinar for today. That's the next piece we would show. But I'll just say a few words about it again. The thought behind this workflow is that you might use a number of measures to try to figure out how to best calibrate your model. So you might build your seed model as your best case of what a building is. Then you might set up a modeling study with a number of measures of a number of different performance values and see how well does that design alternative collection of those measures match the bills. And that's what would show up here in the calibration button if that were active. Okay, so the last thing we're going to do to end the webinar again is I'll just simply turn off the cloud. And it's always good practice when you stop the cloud here in the PAT interface that you also go back to your Amazon instance and make sure that you select those action and terminate them. And it'll say again, are you sure you want to do this? Yeah, I do. I'm tired of being billed. Boom, I just terminated them. So at that point, any part of an hour you'll be billed for, and you'll get the record for that again. It's monthly bills against a credit card. All right, well, that concludes today's webinar. I hope you guys got a lot out of that to see some of the different workflows that you can apply, both the SketchUp plugin, the OpenStudio application, and the parametric analysis tool, while also leveraging the EC2. We'll be having more webinars. The next release of OpenStudio in March, I think March 1st, so we'll have another webinar following its release to share some of the new features of that. And just keep on the lookout. If we see some interesting functionality come out of it, we'll be sure to have a webinar to introduce it to everybody. Thanks so much for joining us today, and we look forward to working with you guys all in the future. Take care. Bye-bye.
The organizer has